All right, so chapter 6 is all about relationships and triangles. We talked about triangles, and now we're going to define some relationships. So our first theorem is the perpendicular bisector theorem. If a point lies on a perpendicular bisector of a segment, then it is equidistant from the endpoint. So what you're saying is if D is here, okay, and it's a perpendicular bisector, then we know that AD is congruent to DB, okay? If AD is congruent to DB, what we can infer is then that the sides are congruent, okay? So we could say that CA is congruent to DB. So we're going to write CA is congruent to CB, all right? Okay, number 2 is just the converse. So if AC is congruent to CB, then we know that CD is perpendicular to AB, and then we know AD is congruent to DB. So the reason why you need to understand this theorem is to be able to solve the problem. So for number 1, they told us that RQ is congruent to QP and that SQ is perpendicular to RP. Okay, so we know that SQ is perpendicular to RP. So then also we know that RQ is congruent to QP. So then we know that these two are congruent, so that means RS is 6.8. Okay? 2, okay, they told us that RT is perpendicular to QS by this. This tells us it's perpendicular to the right angle. Then we know QT is congruent to TS, so then we know that RQ is congruent to RS. So we can set them equal to each other. 7x minus 22 equals 4x plus 5. Solve our equation. 3x minus 22 equals 5. 3x equals 27. X will equal 9. Then they want to know what RS is, so we plug that back in. 4 times 9 plus 5 gives me 36 plus 5, and that gives me 41. All right, 3, find indicated measure, okay? They told us these are congruent, so that means that these two sides are congruent, okay? So we get 7x plus 24 equals 13x minus 48. I'm going to subtract 7x. So 24 equals 6x minus 48. Add 48 to both sides. And I get 72 equals 6x. Divide by 6. And x is going to be 12. All right, 4, find EG. Okay, so this time they told us DE was congruent to DF. So since we know that those are congruent, we can set the two sides equal to each other so that we can say 2x plus 11 equals 14x minus 37. The other thing we're going to talk about today is angle bisector, which it kind of says the same thing. So if AD, I'm going to highlight what they're talking about here. So if AD bisects BAC, so we already know if it bisects, we can assume that it cuts these in half, you know, when we did our highlighting in our last chapter. So it cuts these in half. Then AB is perpendicular to BD, so that this is perpendicular. And then AC is perpendicular to CD. Okay, so these are perpendicular. Then we can say that BD is congruent to DC. All right. The converse is also true. If BD is congruent to DC and AB is perpendicular to BD and AC is perpendicular to CD, then we know angle BAD is congruent to angle DAC because AD bisects BAC. So these are important to know because when you do your justifications on the test, you need to be able to write those. All right, number 1 says find the value of x, so 4x plus 30 equals 9x minus 5. We're going to subtract 4x, and we get 30 equals 5x minus 5. Add 5, 35 equals 5x. Divide by 5, x equals 7. Right, 2. So since this is congruent, we can set these equal to each other. So 5x minus 11 equals 8x minus 41. Subtract 5x. Negative 11 equals 3x minus 41. Add 41. And we get 30 equals 3x. Divide by 3. X is 10. So you really have to have good algebra skills in this chapter. So we want to find the value of AD. So since we know that these angles are congruent and these are perpendicular, we can say these are congruent. So 13x minus 4 equals 8x plus 11. Subtract 8x. 5x minus 4 equals 11. Add 4. 5x equals 15. Divide by 5. X is 3. We want to find AD. So we know AD is 13x minus 4. So 13 times 3 minus 4. 39 minus 4 gives me 35. Alright, 4. We're going to set these equal to each other. 3x plus 3 equals 8x minus 32. Subtract 3x. 3 equals 5x minus 32. Add 32. 35 equals 5x. Divide by 5. X is 7. Okay. Oh, I didn't tell you what to find. Let's find angle YWZ. So that'd be 3 times 7 plus 3. 21 plus 3 gives me 24.